Hi, I'm going to be solving a linear differential equation by the method of integrating factor. The standard form for a linear differential equation is dy over dx plus p of xy equals f of x. And the integrating factor is a special function mu of x equals e to the integral of p of x dx. The differential equation that I'm going to be solving is dy over dx equals x minus 6y, with the initial value y of 0 equals 8. To begin, we want to put the differential equation into standard form. This can be achieved by adding 6y to each side. This gives dy over dx plus 6y equals x. Next, we want to find our integrating factor. First, we identify p of x from the standard equation. So in this case, p of x equals 6. Then we can take e to the integral of p of x dx, which equals e to the integral of 6 dx. This gives us e to the 6x. The method of solving a linear differential equation depends on the fact that the left-hand side of the equation can be written as the exact derivative of a product of the integrating factor and y. So if we multiply the integrating factor by both sides of the equation, we get e to the 6x times dy over dx plus e to the 6x times 6y equals e to the 6x times x. Now, the left-hand side of our equation is the derivative of the product of e to the 6x times y. So we can rewrite this as d over dx of e to the 6xy. We can now integrate both sides of our equation with respect to x to arrive at the general solution. If we integrate the left side of the equation, this gives us back e to the 6xy, because we're taking the integral of a derivative. Now, to integrate the right side of the equation, we use the method of integration by parts. To perform integration by parts, we use the integration by parts formula, which is the integral of u dv equals uv minus the integral of v du. First, we must identify our functions for u and dv. We're going to choose u equals x, because that gives us a simpler derivative, so that our du equals 1 times dx. Then we set dv equal to e to the 6x. Now we can take the antiderivative to give us v, so that our v equals e to the 6x over 6. Plugging in u, v, dv, and du into the formula for integration by parts gives us the integral of e to the 6x times x dx equals x times e to the 6x over 6 minus the integral of e to the 6x over 6 dx. We can now solve our second integral. This gives us x times e to the 6x over 6 minus e to the 6x over 36 plus c as the solution to the integral from the right-hand side of our differential equation. We can now set the left side equal to the right side to give us e to the 6xy equals x times e to the 6x over 6 minus e to the 6x over 36 plus c. Next, we want to solve for y to give us the general solution as a function of y. If we multiply both sides of the equation by e to the negative 6x, we get y equals x over 6 minus 1 over 36 plus c times e to the negative 6x. This is the general solution to our differential equation. We can now plug in our initial values to solve for c. If we set y equal to 8 and x equal to 0, we get 8 equals 0 over 6 minus 1 over 36 plus c times e to the 0 times negative 6. Simplifying gives us c equals 289 over 36. We can now plug our value for c back into the differential equation to give us the general solution. Y equals x over 6 minus 1 over 36 plus 289 over 36 times e to the negative 6x. And this is the final solution to our differential equation. Thank you.